use it. Alright guys, so the first one, if you have a problem like that on the test and you get the answer but you don't show me any algebra, you will not get any points. Right? This is algebra class, so we have to show me algebra. This was actually a quiz that I gave last semester. There was a game the Lions and the Packers played. They did score 31 points total. So this is from a real game from last semester. Are we what? What kind of question was that? Was it baseball or something? I love it. This was not a baseball game. If that was the question. You can tell that from the score alone. You can't tell the names. Alright guys, so help me out. What's the first step? That's the second step. What's the first step?
Green Bay.
I like it. So we got Packers and the Lions. So, right. So he gave his part. That's the part he knows. Now you come in with yours.
Then for Green Bay, you want X14?
All right. Let's slow down a second. What? Who is just X?
X is the Lions.
Why is the Lions just X? Not just because you don't know, because there's two things I don't know. One of them is going to be X, though, because the other dude or dudes depends on it, right? The Packers scored 14 less than 4 times. The Lions, I got to go know the Lions first, because the Packers depends on them. You with me? So the first step is the English. Just who are the players of the problem. And really, what really is it about these two? It's the number of points they scored, right? Okay.
4x minus 14.
Not there yet, but we're almost there. So you guys said the Lions are X. I love it. Bless you. Because the Packers depend on them. And now that I know that these guys are X, I can write 14 less than 4 times this. So 14 less than 4 times that. So if you got 14 minus 4x, you'll have teams scoring negative points. Which some teams it seems like they do, but nobody's that bad. You lost 2 points in the very first. No, how do you do that?
4x minus 14. No, x plus.
Yeah, what are those two supposed to do?
X plus 4x minus 14 equals 31.
Yeah, because it says together they scored 31 points. So the points these guys scored plus the points these guys scored. It's 31. So the most common mistake I see is somebody says 4x minus 14 equals 31. That's normally the person that didn't do this step. If you do this step, you can see both parts. Both parts have to be in the equation. If you skip this step, you just focus on the 4x minus 14, and then that one team by itself scored the 31 points, which, they wished. They didn't do that. But now I got this team plus that team scored 31 points. And now I can just solve this equation, right?
So over plus 14.
3x.
Oh, no.
5x.
4x
Five
plus
plus
5x equals 31. So both sides would plus 14.
Sue's in the wrong place?
14.
14. So then you have to
Plus.
Plus
add 14, I like it.
45.
45, I like it.
So 9.
And then you almost always divide last.
5.
Okay. And what does that mean? I mean, don't leave it like that.
I mean, the Lions scored 9,
Yeah, Lions scored 9 points.
and then the Packers scored the rest.
Packers scored the rest. So 4 times 9. 4 times 9 minus 14. 36 minus 14. 22 points. And to check it, 22 plus 9 is 31. So it looks pretty good. Now remember, if you check it and you set the equation up wrong, the checking will actually come out okay, but you're working with a bogus equation. So there's no way you can catch that just by checking the numbers. Okay, how are we doing so far? Is that cool? Yeah.
Don't understand.
Got to come see me. So what section is this from? This is from section
3 points.
3, 4, that last section in chapter 3. All right, so not everybody has tried that yet that I know of. I have not gotten everybody's homework from that section. So I am not sure yet exactly how this went. Okay. So let's go on. The rest of this should actually not be quite as bad as that one, hopefully. Number 2A. I like it because it's 5 out of 10, which reduces to 1/2. I love it. And then B. Good. You got 2 and 3/4. And just because, what would that be as an improper fraction? I didn't ask for it, but
1/3.
11 over 4.
Where you at?
11 B.
11 over 12.
No, 8.
11 over 12.
11 over 12. 11 over 4.
11 over 5 or 6.
11 over 4.
11/4. Now again, if you look at this, each one of these little pieces, right there represents how much?
1 fraction.
1/4. I love it. There's no 12ths here. Each one of those represents a quarter of the thing it's out of, right? So if I say, okay, how many is shaded in? You can do it the same way as the little paper. How many? So 1/4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/4. And thank God that equals the other way to look at it, 2 complete ones and 3/4 of the last two. So these numbers have to be equal to each other. So if you put 11/12, that doesn't equal 2 3/4. That doesn't make any sense.
If we just write it 11 over 4, is that okay? Or
Yeah, if I don't ask for one way or the other, then you can put either way you want. Yeah. On the test, I'll probably make it more like the homework did. The homework said if you put it improper, put it also as a mixed number, yeah. And what about part C?
it's 9 over 24.
Good, so 9 are shaded, 24 total. And of course that, good, divided by 3, 3/8. Cool.
So we have to do that?
Yeah, you should always simplify fractions wherever they are. It's just your last step in any problem is just to step back and say, can I reduce that answer I got? Yeah.
So we times by 3.
Well, we have to divide by 3 because that's what's common. So I'm always trying to bring it to lowest terms. I want to make the numbers as small as I can. So I know 9 divided by 24, if you did that, it would be the same thing as 3 divided by 8. They both come out to 0.375 if you divide either one of those. But that just looks a lot better than that. It's smaller numbers. Yeah.
I just did it the other way. Anyway. I did it 3 times 3, 3 times 8, and then crossed them off. I did it the long way.
No, it's fine. Yeah, it's beautiful. So 3 times 3, 3 times 8, kick ass.
Same thing, right?
Same thing. Because you're dividing 3 out of both. Cool. So what about... Yes, sir.
That'd be 5. Because you can't take 8 to 3, it's 5. 5, 6, 7, 8.
There's no subtraction. No subtraction.
Can't subtract.
I don't have any subtraction in there, do I? It's division.
Divided.
It's division. So I can't divide 3 by 8. 8 minus 3 would be 5, but there's no minus. Alright guys, what about this one here? Rewrite 43/7. How do you do that?
6 and 1 7.
I like it. So you go 7 into 43, 6 times. 6 and 1/7. Cool. Yes, sir.
That's 251 out of 7.
Say again.
Not 251 out of 7. Divided times.
Oh, now be careful. See, so this bar here means what? What does this mean?
Divided
Divided by. But what did you do?
times.
Totally different. Exactly opposite. So if you see this and I ask you to put it as a mixed number, guys, that bar means division, so that's exactly what you do. See there, Randy? Randy, look. You told me that bar means division, right?
But it's
So
not-
what did we do to do this problem? We divided. 43 divided by 7. We actually did the division. And I've seen you do this before. I know you know how to do this.
I know how to do it, but it's
But it's not times. This is exactly the opposite of times. This is like you told me, this is division. I have to divide those two. Yeah.
How do you know when to put that one? Like, how do you know it was 1 over 7 instead of 7 over 1?
Because I had one left over.
Because I always goes on the, whatever's up group always goes on the top. Of the
Yeah, this
remainder?
number up there is what we used to consider as the remainder.
Okay.
And I showed you, I don't know if you guys remember this, but it's always good to remember 43 kind of sucks.
Right,
It's too big. If only it was just 42,
right.
then 7 would go in evenly. So I can write this as 42 plus 1. Guys, so I can write it like that. This is exactly why this works. Because what am I dividing by 7? 42 and 1. I'm dividing both of those by 7, right? So 42 divided by 7 is 6 and 1/7. That's the long-ass way to do what we did here. You guys kind of with me?
Yes.
That's exactly why writing it as a fraction actually works. That fractional piece is the extra that's left over that 7 didn't go into.
So where'd you get the 7?
From here, from the beginning.
And then you put 1?
Because it was 1 left over. Now I'm saying, you don't have to do it this way. And actually, if you like this way, you could do it that way. There's nothing wrong with that way. But this way is just a little bit faster for the most part. Okay. What about number 4, going the other way around? That's normally a little bit easier. Yeah, 11 times 5. 55 plus 3. All right. Yes, sir.
So you add 55 to get add 3 or divide by 3?
Yeah, you add 3.
That 3, so 58, 11?
Exactly. Cool. I like
Okay,
it.
cool.
And again, I think I showed you this before, guys, and let me know if it's not true. Does somebody remind me, what is 5 and 3/11? What operation is kind of missing in the middle? Plus 11. So this is really 5 plus 3/11, right? Now we can see this a little better now that we've talked about like denominators. What's 5 over? 1. Good. Every whole number is always over 1 if you need to. Now why can I not add these?
Because
They're not like.
like terms.
So what's the LCD going to be? It's almost too easy when one of them's 1.
10.
The LCD is going to be the other dude. So how do you make this guy become 11?
10.
Times 11. Got to do the same thing to the top. You with me? So 11 times 5. Didn't we just do 11 times 5? Plus 3. That's what we would do next, right? This is exactly why the shortcut works. That is why the shortcut works. You with me? So if you only know the shortcut, that kind of sucks, because then you might start doing it wrong or at the wrong time. But if you see why the shortcut works, then you have a little more faith in the shortcut. You won't do it the wrong way, hopefully. All right, maybe. So what about number 5? That's the reducing of the fractions.
Should be 8/5.
So we got 5a. If I want to do this like Carl did earlier, how would I write the top? What do they have in common? 5. So 5 times 3?
5 by 5.
5 times 5?
3 over 5.
3/5, 11. Cool. And again, if you did 15 divided by 25 in your calculator, you would get 0.6. 3 divided by 5, 0.6. So that's why math doesn't care which way you write it, they're both the same number. How we doing?
What if you would divide it by 5?
How do you mean? Sorry.
Say you divide 15 by 5, you divide 25 by 5. So it's good.
Oh, yeah, sure. The other way to do this problem is like we did earlier, just a little more direct, right? Divide by 5, divide by 5, you still get 3/5. Cool. What about part B?
8 by 2. 8 by 2. 8 by
2/3. What?
3 2 4.
3.
8 and 5. 8 and 5.
I like it. So 8 times 2 is 16, 8 times 3 is 24. So the 8's cancel? 2/3. How far apart are 16 and 24?
1.
They're 8 apart, right? 16 and 24? You remember that? We talked a little bit about that last time. I think a few of you guys kind of got what was going on. They're 8 apart, so 8's a good thing to try first. Because maybe it's multiples of 8. And if that doesn't work, maybe 4 would work or 2 would work. What about part C? I throw some letters in there just to be that way.
4 by 8.
I like this. I've seen people doing this. What number do these have in common?
2, 4.
4.
4.
4 times.
4 times 8.
8.
12 is
4 by 3.
4 times 3. A squared is
8.
AA. So the 4's
4
and the A's.
8 over
Not all the A's, right? Just one of the A's. So numbers and letters work the same way. It's just that letters are actually always factored already. Numbers I actually have to factor. So to be honest, letters are easier. They're not easier for us because we don't work with them all the time, but they actually are. They're always freaking factored already, right? Numbers actually got to freaking factor first before I can see what the hell's going on. Here I got a couple A's, 1 A, so 1 cancels. I got 1 left down to here because I had more of them there to begin with.
3 A's.
So what do I have left over here?
8 over
8, B,
over 3.
3, 8. Okay. So the hardest thing to do is leave a survivor behind. Right? Me and my zombie movies in my head. Make sure you have all the survivors collected over here. Don't leave anybody behind, right? For the zombies to eat.
But I didn't do it.
How'd you do it? Did you do it a little more directly?
Yeah, I use 6 and 16. 16 and the, 6 and the 30.
Yeah, 6 won't go into 32.
16, then 6. Oh yeah, I used 2.
Oh, I see
Started
what
off
you
with
did.
2.
I got you. And then you did one
16 on
more.
the 6.
Okay. But then one more step will get you to 8 over 3.
Yeah.
Yep.
Right. How about the 8 B's and 3 A's?
Because that's what was left over. Are you okay with 32 is 4 times 8?
Yeah.
12 is 4 times 3?
Yeah.
So the 4's do what?
It's 8.
The 4's cancel?
Yeah.
Right? So look what I have. What numbers do I have left?
3,
An 8 on the top
8, and then
and a 3
3.
on the bottom. Now what happened with the A's? There's 2 of them down there and 1 of them up there. So what happened with the A?
3 A's and 3 B's.
One of the A's
Cancel.
canceled. So how many A's are still on the bottom?
1.
Good. 1 A on the bottom. What letter is still on the top?
1 B.
1 B. There you go.
So 1 and
That's
1.
how we got there. This is exactly how we got there. We just collected who was left on the top and the bottom.
Can we take the, we did like take that and then just do 1 and 1, that's it?
That's it. Yeah, because every time you reduce something, you're leaving 1s behind. But I don't have to have them show up because 1 times anything is itself. So they
Right.
kind of stay hidden. Cool. How are we doing so far? Okay. And then the last one, since this wasn't really a real quiz, I decided to put something on here that we just did last time. Officially. So some of you guys forgot what this meant. This is like prime factor tree. Right, where you just kind of break it up and then keep breaking things up until you're done. Get the DNA of it. Yeah.
I put 9, 2, and 2, 4. 2, 4, it's 8.
Okay. Does 8 go into this?
No, it's 2, 9, and 2, it's 8. Wait.
You got to think about what goes into 198.
99. Wait, I did 99.
I like it. So 99 times 2. Now some of you guys might not have seen that. Some of you guys, well, you probably did by 2 and then divided and got 99. That's cool. So 2 is prime.
11 by 9.
3 by 33.
9 by 11. I like it.
I did 33 by 3. Doesn't matter.
That's crazy. No, that's fine.
It's gonna be the same.
There are multiple ways, exactly. There are multiple ways to kind of do the first steps, but it always will agree at the end. Right? Because there's multiple ways to multiply things. There's multiple ways to bring them apart. And of course, 9 is...
3 by 3.
So how do you really collect this together for me?
2, 3,
2 times
2 times
Yeah.
3.
3
Second part.
squared times 11. There you go. So that's the DNA of 198. Yes, sir.
Not like 1199, like 199, like 99, 11 times 99 is 99.
11 times 9 is 99, but we're going the other way. We're breaking them up. We're breaking them apart.
11 times 9.
99. But we're going the other way. We're breaking them back up. All right, guys, what about part B? 480?
240 times 6.
224. 2 by 24.
All right, 2 times.
200, 240.
All right, and you might have done it a different way. Yeah, some of you guys might have done 10 times 48. If it ends in a 0, you can automatically suck that 10 out, right? So that'll be fine. We have to agree at the end. Yes,
I
sir?
put 8, 6, and 0.
Oh, so you did 8 times 60?
Yeah, I mean,
I like it. Let's see if we match up. What can you do with this?
120 by 22.
All right, 2 times 120. And of course you can do again
2 by 60.
2 by 60,
And 2 by 30.
2 by 30,
And 2 by 15.
2 by 15.
That's it.
15 is
3
Oh, 3 by 5.
3 by 5.
Yeah.
That's 6.
So guys, no matter which way you do this, you have to end up with how many 2s? How many? 5. So 2 to the 5th times 3 times 5. So Randy, even if you start, say again?
Where's the 3?
Right at the end, 15 was 3 times 5.
So, Mr. Jeff, can we do it by easy way?
Yeah.
Is that the only way? That
No, hell no. All right. So what's another way to do it?
Yeah.
What did you do?
I do just like this one.
You did this?
Yeah. Yeah, one of.
So what if you
Okay.
did
I'm
48?
going to find the other one easy. Because
All right. So if you did 48 times 10.
2 by 5, 10.
Yeah, 10 is 2 times 5. I like it. 48 is,
2 by 24.
or even let's say 8 times 6. And what's 8?
2 by 4.
And what's 6?
2 by 6. 2 by 3.
And 4 is 2 by 2. So let's figure out 1, 2, 3, 4, 5 2s, a 3 and a 5, right?
It's the same thing.
And if you think about it, it only makes sense. When I multiply these numbers together,
Yeah, we'll get 400.
I'm going to get 480. So no matter which way you tear 480 back apart, you're going to get these pieces. Right? I don't care which way you tear it apart, they have to come down to these pieces because these pieces multiply back to be 480. That's the only pieces that do. Yeah.
I did 2, 2, and 8, 10, and then,
Yeah, you did, you told me you did
yeah,
8 times 60.
it's 8, 6, and then 0.
Yeah, so this would be
And then
2 times 4.
Then I put 5 and 12, then 3 and 2, 6,
4.
4, 3,
So you see this at 1, 2, 3, 4, 5 2s?
yeah,
A 3 and a 5.
yeah.
Good. Yes, sir.
Hey, below that 15, did you say 3 divided by 5? Because that looks like a division line between it. I thought you said divided by.
No, hell no.
Oh, okay, I just cut
Yeah, I would never say that. That would hurt. Just to actually say that, it would hurt me. That wouldn't make any sense. This is all about carrying it up into factors, and factors mean that they are multiplying. That's what that word means. It's part of a multiplication problem. Okay, cool. Not too bad. Right, so I think some of you guys would have been fine if that would have been a real quiz. Some of us might be happy that wasn't. I don't know. All right. Let's see. So let's get into any questions from homework.
What is the
All right. What are we at? About halfway through the semester?
There we go.
Can we get like a bonus point?
No.
I'm just kidding, Jeff.
I love it. I will give myself some bonus
So
points.
this doesn't count?
I'm doing really well. Huh?
This doesn't count?
Say, I'm sorry?
This doesn't count?
No. But you can use it to study from if you want to. And I have a practice test I'm going to give out later.
The same test would be the same or different?
Same kind of stuff. All right, guys. We're not done. Hopefully, everyone understands that. Some of you guys might have to leave for other things. This is college. You can leave any damn time you want to, but I'm going to keep going. So, any questions from homework?
Yeah, I have a question.
Where are we at currently? Does anybody know?
You have,
I love it. We just did 4.5.
Do we have questions on 4.7?
We haven't done 4.7 yet officially, so hold on to those. We haven't talked about it yet. Yeah.
Do it 4.2 still. Stop.
All right. That's not horrible, but you want to be moving along. Yeah. You got time. So, guys, just to kind of focus you a little bit, what's happening a week from today?
Quiz.
Test.
Test.
I think last year.
Yeah. So don't forget that homework sheet has all the important dates, and I'm going to try to not change the test dates so you can kind of plan around them, all right? And make sure that you are free. Huh?
We need to practice that.
I have one. I'm not going to give it to you yet.
Come on, man.
All right, cool. So no questions from homework? Say again?
Last day for the.
All right, guys. Structural question for the class.
I know.
When's the last day to turn in homework so it's not late?
Before the test.
The day of the test. When should you turn it in? As soon as possible. I like it. As soon as you get it done, turn that thing in, because I got more time to look at it, right? Some people, I have not graded the homework you turn in on the first test. I'll grade that as soon as I can. It's much better to turn it sooner, yeah.
question from like.
All right, wait.
From Leo.
Guys, hey. Guys. Yeah, what he said. All right, so what's up?
I have a question from like last section 3 or 4.
Page 304? No.
No, exercise 3 or 4.
3.4?
Exercise 3.4.
3.4.
Question number 51.
51. Okay.
Oh, I'm sorry. Yeah, 51. He said like we change the example, like but it depends on the other one. How can we do it?
This here?
No, like so example 3 again, but this time let x be the distance from.
Wait. This is not 3.4. What section are you in?
This one. The question.
You have a different book than I do.
Oh, really?
Yes. That could be a problem for you. Does it say International Edition on the front?
It's 5th edition.
Okay. So we have the 6th edition.
Yeah, I know, but it's same exercises. Just the page is different.
No, it's not. The 51 for you is different. Mine is round this to the nearest thousand. So just when you do your homework, you want to make sure with somebody else that it really is the same.
Oh, really?
It's different there for you. Yeah. Yeah, I didn't assign that one. No. All right. So let's try this again. Any questions from homework?
Yeah. On 4.3, if we do that?
Yeah.
All right, page, I don't know, question 36? I don't know what page it's on.
I got you. Page 242, 36. What does y cubed mean?
3
Y over y, right?
Yeah.
So, going back to what I said before, when I say that right here, that part does not have the number 3 in it at all. I know it's got a 3 in the exponent, but what does it really mean? It just means 3y. So what does that really have in it? Y, like you said.
3 Ys.
3 y's. So, I can't possibly have a 3 left over here, for example. I can't remember who it was. I saw somebody do this.
No.
There is no 3 up here. That would be if it was this. If it was this, that would be fine, right? Because then these y's would cancel. Because I have 1y and 1y. This, I've got, what do I have to do with that to really see what dies? If I have y cubed over y squared.
3 times y.
Y, 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 and y, y.
2y.
So that's one.
Bam, bam. 1y. Good. Good. Because. Yes.
Why is 1y?
Because there's 3 up top, right?
Yeah.
There's 3 up top, just like that.
So 3 minus 2 equals
And there's
1.
2 down there.
Says 1.
I like it. So Randy just hit on a pattern I think that we talked very little about last time. 3 minus 2 is
1.
1. And that actually holds. And I think we did a couple examples that were just like that. But if you don't like that shortcut, if you're not sure how it works, you could just expand them and you just kill whoever's coming.
Can we just put 1 or just 1? We have to do y.
The 1 means 1y. 3 y's divided by 2 y's leaves you with 1y. Understanding that those are powers I'm talking about. So that would help me out of that x to the 80th over x to the 78th. I really don't want to write 80 x's out, and I really don't want to watch you do it either.
That's
Right?
18.
Well, what do you think's going to happen? How many x's would cancel? 78. How many would be left? 2. Where? On the top. Because 80 minus 78 is 2. So that, in this sense, that minus is not really subtraction. It's just realizing that I am crossing out that many. So in effect, I am subtracting the number of y's away. But it isn't really subtraction. It's just kind of like the way it works. It's a nice shortcut to the way it works. Okay, maybe. So let's look at this problem here. That kind of thing's going to show up in a minute. How do I divide fractions?
3 by
3 minus 3.
Flip them over and multiply.
3. Flip which one?
3 and 9.
Always the second dude gets flipped, right?
3.
Always.
3.
So 3 over y squared times.
3y. y
3, 5, 3 over 9.
I like it. So that's how division works for
3
fractions.
times 3 is 9.
Say again?
3 times 3 is 9.
Good, but I don't see a 3 and a 3.
Okay, 3 times 3 is 9.
But I only see 1 3.
So we cancel.
That 3 means what? Y. Y cubed means...
So 3
Y,
y's
Y,
times
Y.
3 y's is 9 y's.
Nope, I don't have 3 y's over here. So what I have here, I got 3 over y squared. Y squared is y. Y cubed is
3 times
y.
over 3
I like it. Over 9 is 3 times 3.
So 3 cancel 1 3.
Now, I'm not saying that everybody has to show me this level of work. But if you're not comfortable with this, you can always break stuff down and then just start individually killing things that are the same on the top and bottom. So, for example, this 3 and one of those 3's. Right? That 3 can't kill both of them. He's dead after the first 3. He ain't around anymore.
So y over 3.
So what happens to the y's?
2 over
2 y.
Yeah, 2 y's kill each other.
Y over
So who's left alive?
5 over 3.
Y over 3. Cool.
Yeah, I got carried away.
Yes.
So, don't get it.
So it's all about if I had 80 over 15, for example. Right? If I had 80 over 15, they both have a factor of 5. Good, because they both end in 0 or 5. So 15 is 5 times 3. 80 is 5 times
3.
80.
15.
Real quick, stay with me. Most of you guys know what 5 times 12 is, right?
That's 1. 2.
5 times 12?
2.
16.
Okay, so now we all know that.
14.
So when I'm trying to tell you honestly, I got to think for a second about like 80 or something. And all I do is, if 5 times 12 is 60,
It will be
2 more 5s would be 70, because every 2 5s is another 10. Are you guys kind of with me? So 5 times 16 would be
80.
80.
That'd be 1.
Good, what would be 1?
be 16 times 15 is 80, and then 80 is 1. 80 on 80 is 1.
What can I do right here? What can I do? What's common on the top and bottom? What's the
That'd be
same?
8 and
What's the
1.
same on the top and bottom?
Be 8, 1 and 8.
What's the same?
That'd be 5, 3, 5.
What's the same on the top and bottom?
5.
5. So the 5 can cancel because it's 5 divided by 5. And what's left? 16 over 3. So I think you're trying to do too much with it. You just have to work with exactly what you see. You don't have to go any further with it. So the 5s go away, and I can see what I'm left with.
Not 19 over 3.
Not 19. I can't add the 16 and 3 or something. Yeah.
Not subtracting.
Nope, no subtraction in here. It's just division, right? Yeah.
Now, I mean, you have 3 3s and you have 5 Ys, and you're killing the Ys, but you left 1 Y left and 1 3 left.
It's not that I left them. Let me go back to here. So I had 3 over y, right? Yeah. Times y. Y. So I just work with what I see. If I see a 3 on the top and a 3 on the bottom, what can I do with those? Cancel. 1 3 1 3. I didn't choose to leave the other 3. Is there another 3 to kill him? No, so it's not a choice. I like it. So I want to be careful about your word choice was bothering me. So of course the y's, that y kills him. That y kills him. Right? Or whichever y you want to kill, as long as you only kill one of them. Right? And then you can see what you're left with. Cool. I like it. Okay. Now, and this is the most spelled out level. Some of us don't have to go break it down all the way there, right? You don't necessarily have to show me all this work unless you really need to. Some of us should probably be able to, from right here, just say that's 1, that's 3. 2 y's, cancel 2, leave me with 1. I mean, that would be enough work for me if you're a little concerned about me doing this. If you can do this and it makes sense, you can do this much work, right? So then you just collect your survivors. Good. Or you do that if you need to see what the hell's going on, right? So it all depends on how much you're comfortable with. Okay. Yeah.
So that is good. So if we don't do the big thing, can we do like that?
You can do this if it makes more sense. Hell yeah.
So
if I had 10 over W4 times W squared over, what you got, Jeff? 25.
20.
What goes into both of these? 5. 10 divided by 5 is 2. 25 divided by 5 is 5. How many W's would think cancel?
2 W.
2 W's. How many would be left?
4.
Now see, that's where we run into trouble.
No.
So some of us shouldn't do it this way. So 2 W's would cancel. How many are left?
2.
Where?
2 out of 5.
Down here. Why are they left down here? Because that's where more of them were, right?
8 and 5.
So again, if you need to, W, down here. And that's, of course, the next generation of internet, I guess. What? World Wide Web. And so you can see that this W kills, that W kills, and you have the 2 down.
2,
right?
4 2s.
So again, it's all about how much you're comfortable with.
They gotta make a grade on that.
You better make that if you take it.
I'll leave it alone.
No rebound over there. You got nobody over there.
So
Yeah.
the answer is 2/5.
Yeah, the answer here, careful now. I agree with you. 2's on the top and 5 is down there, but what else is still there?
2 W2s. And
There.
then
That's it.
So you would just bring the W's over along the same.
Exactly. Wherever they're left alive, that's where they are in the answer.
Okay.
W squared times 5 is 5W squared on the bottom.
Yeah.
Cool. I like it. Let's see.
How about number 45 on 242? There. I might did I do too much homework for you guys? Sorry guys, I didn't do my homework.
6 and 4.
What does something squared mean?
Something like something itself.
So then rewrite this as -3/4 times Negative 3/4. That's what the square means, right? And now you just attack. Can you cancel anything? Hell no, because there's nothing. The 3 doesn't go into 4.
You don't flip it.
Why don't I flip it? Because exponents are based on multiplication, and it's only I only flip when I have division. So that exponent means this times itself. It's times already. No flipping needed. It's not divided. So now I can just multiply. What's negative 3 times negative 3? 9. And what's 4 times 4? Yeah. And watch this real quick. What's negative 3 squared? 9. What's 4 squared? Yeah, so you don't even have to write that out. You can actually just square both of these.
I get it because 16 is
4 and 4.
No,
Because I have 2 4s and 2 3s. Good. I like it. Okay, so anything else before we get into new stuff? Okay, so the nice thing here is I'm only going to do one more section tonight. Before I do that, quick review. You guys try these problems out here before we get into the new section. A real quick side note, guys, while you're thinking about this. Can I add those?
No.
Why not? They are not like terms. They're not like terms. But does anybody know what that is?
Yeah.
What is it?
2x.
No.
X, Y, X, Y, X.
What was it? This is x, and what's x squared?
2
X squared.
3.
3,
That's what you said.
because it's addition versus multiplication.
So can I add not like terms? No. Can I multiply not like terms? Yes. So when I'm adding or subtracting fractions, I must have like terms, which means what with fractions? Like denominators. When I multiply them, I do not need like denominators. I don't need like terms when I multiply. Yes, sir?
Because so you add 2x and then you add another one, be 3x. So that's
Yeah,
2x.
I love it. So it's a string of, there's 1 and then 2 more at the end makes 3 total. And here's an even better one. What's 4 plus 2y?
8y.
Careful.
Can't do it.
Can't do it. I like it. Even better. 4 plus 2y, Jeff. What do you want from me? I can't add those because, again, they're not like terms. Well, what's 4 times 2y? Now come at me.
4 2y. 8 2y.
8y.
8y.
I like that. So these are not like terms, but like terms only relates to adding, subtracting. Multiplication doesn't care. 4 times 2y is 8y. There, I multiplied them. Nah. They're not like terms, but multiplication. That's why when I multiplied, did we worry about LCD when we were multiplying and all that? No, we didn't. We didn't have to. But when you add and subtract, you've got to have like terms. I was saying it's never going to get together. You can't combine them.
Because you add 4 plus 2, it's 1.
But it doesn't say 4 plus 2.
Because you add.
4y plus 2y is 6y. 4 plus 2y, not like terms.
That's 2.
How many y's do you see in this expression?
1y.
No, come on. I see 2 y's, right?
2
2 y's. So if you tell me this equals 6y, I only see 2 y's. I don't see where you see 6
So 2
y's.
plus 2 is
Here
2.
I see 6 y's, right? Sorry, guys. And it was like, it's out of the way. And yes, it's fine to get a negative fraction. guys done? You want to come do it up here? Yeah.
I don't understand that one, cause,
Number 2?
yeah, cause I don't, do we add?
You can only add them if they have the same bottom, right? So what you have to do up here?
My, it's like 1/3. I don't,
They have to have the same denominator, right? This is a 9. This only has a 3. So how would you make this become 9?
3,
Multiply by 3, right?
3 and 1, 3 and 2.
Whatever you do to one side, you have to do to the other, right? So 1/3, I can build it up. That's the opposite of reducing. Kind of would be reducing, I would divide them out. Building it up and multiplying it back in. So that's really all there is to it, Randy. You say they're not the same on the bottom. How do I make them the same?
That'd be 3, 3, 9, and then 1.
Yeah, this would be 2 9s minus
1. 3, 9.
1 times 3? 3 times 3?
So,
Only the bottom.
So that's what you guys got so far? And then what's the last step? What's 2 minus 3? Good, negative 1 nice. Good. So if you can have negative numbers, you can have negative fractions, no problem.
I don't.
2 ninths minus 3 ninths.
I know that, but I don't understand. And the math, it's algebra is like it's not in my
I know.
head.
But you gotta come see me. You still haven't come see me at all. So you gotta come see me. So what about this guy?
Gotta find the LCD.
Yep, gotta find LCD. Cool. So how do you do that? The way I showed you is just one possible way. I really want to make that clear now. If you have a way to find an LCD that isn't like the way I showed you last time that was on the handout, you use your way. Do it so I can see what the hell's going on. If I like it, I might start teaching it that way. I don't know. So we have very different ways. I personally would do it the way that I showed you because that's obviously the way that I like it. But can anybody tell me, how did you get the LCD here? Did you get it?
9 times 3 and 9 times 4.
All right, good. So 9 times 4. So that 9 is what they have in common, right? So let me do it this way, sir. Let me make it really clear what's going on. So I'm going to rewrite this as 11 over 9 times 4, 2 over 9 times 3. Now, which one is missing something the other one's got? They're missing, right? Good. So this guy's missing a 3. He's got the 4. He's missing the 3. So it's like you have little kids. And if you have little kids and you give one a bowl of ice cream, the other one a bowl of ice cream, and the other one's got a little bit less, that ain't going over, right? No, I got more now. Okay, you give him. So you got to give him the 3 he's missing that he's got. And now he's all like, oh, what the hell? So you got to give him the 4 he's missing the other guy's got. Now they're both still angry because they don't like that flavor ice cream. But oh well. Now do you see how they're both the same on the bottom? Right? What is 3 times 9 times 4?
108.
108. So I get what over 108? I get 33 over 108 plus 8 over 108. 41 over 108. Just add them up. 33 of these plus 8 of these is 41 of these. Yes, sir.
9 times 12 is 108.
Yeah, 9 times 12 is 108. Cool. That's where we got that from. And now I'm allowed to add them because they're both the same on the bottom. Okay. Cool. All right, so let's do the new part. And then I'm kind of hoping to let us out of here early today. Let's see what happens. Yeah. Thanks for your fake being upset over that. So we don't do section 4.6. It's not on your outline, right? It's not on your homework sheet. It's not in our curriculum, so we're not going to do it. 4.7 deals more direct. I think somebody said earlier, might have been you, Randy, I can't remember. When are we going to do like mixed number stuff? Right now. So what do I mean by that? I mean, all the stuff we've done with these kind of fractions, you have to have a way to do it with mixed numbers. So the simplest problem you would see would be something like this.
We can do it too. 7.
So I mean, if I set it up like this, it might be a little bit easier to see, maybe.
What number is that? 4.7.
What's that?
What number is that?
1 and
That's one I made up.
1 and 2. 1 and 2.
This number. What's up?
So every like in the bottom be the same.
Now, this is an easy example. This is easy for two reasons. One reason you know, the bottoms are already
Same.
the same. Another reason you don't even realize yet is this number is bigger than that number. If they were turned around, you'd have to do something akin to borrowing. That's okay, he's dead.
Then you gotta borrow from the whole number and all that crazy.
He's almost dead. Alright. So this is not too bad, right? 5 eighths minus 3 eighths is 2 eighths. 4 minus 3 is 1. 1 and 2 eighths is not a good place to stop, though. 1 and 1/4. Good, because you can divide those by 2, right? Just reducing that fractional part. So that's a nice place to start, right? Now let's go to the not so nice place.
4 and 2/7 times 1 and 3.
And actually, before we get there, let's focus on this. We'll do multiplication division after we do addition and subtraction. So to run into a problem, all I have to do is this. I could have 11 and 3/10 minus 4 and what you got, Jeff? 4/5. So went from really nice to actually not so nice. Yeah.
That was 1/5. Because it's 1, 1 is 5.
Be careful. I can't do anything with these yet because they don't have the same bottom.
Because it's
They're not like terms yet. They don't have the same denominators.
so it's 16 and 5ths.
Oh, you're thinking about how to change it?
Yeah.
All right. So I'm going to require that you know both ways of doing this problem. One way is to change the form of these into improper fractions, right? So what would this be as an improper fraction? So one way to do this,
20.
113.
110 plus 3, 130.
okay? Cool. Minus,
5.5.
good. 5 times 4 is 20 plus 4. Good.